This lesson is on partial fraction decomposition. Okay, and as awful as that might sound, it's a way that we can take fractions and separate them. So, you know, if you've got two fractions and you get a common denominator and you add or subtract them together, then you end up with one fraction. Well, this is the process that you go about to undo that, okay, to get back to two or more fractions. You can read through this. It's a lot easier if we just look at some examples, and we'll look at the cases all together also, because there's 4 different cases that you'll have to learn to use for partial fraction decomposition. So let's start with this first example. So what we do with this first one is, excuse me, we need to be able to figure out if we separated this so that we have x minus 3 under one fraction and x plus 4 in another fraction, what would go on top, okay? We can't just say 5x on top of the x minus 3 and minus 1 on top of the x plus 4. It doesn't work that way, okay? So, in order to figure out what we have on top, we'll call them A and B. And then we'll go through a process of steps in algebra that will help us figure out what will go on top of those. So I'm going to rewrite our initial expression right here. And what we do is we have to solve this for A and B. You'll see what I mean as we go further, but to start off with, to solve this for A and B, we need to get rid of the fractions. In order to do that, we multiply everything by the common denominator, which would be x minus 3 times x plus 4. When we do that, we'll end up with this. It gets rid of the x minus 3 times x plus 4 on the bottom there. Gets rid of this x minus 3 and puts an x plus 4 up here. Gets rid of the x plus 4 and gets an x minus 3 there. So we end up with this. 5x minus 1 equals A times x plus 4 plus B times x minus 3. Okay? Next step is just to go ahead and distribute. So we've got 5x minus 1 equals ax plus 4a plus bx minus 3b. Now, what do we do with that? So let's pick this up. I'll bring it to the next page here. Oops, didn't mean to do that. I think that'll bring it over there. Okay. So, at this point, what we do is we need to separate this into 2 equations so that there'll be a system of equations so that we can solve for A and B. Now, we don't care about x. X is going to go back in the end, but it's not really important to us at this point. It's only helping us separate out. So what we do is we first take, everywhere we see an x, I'm going to underline it, and that's going to give me my first equation. A plus B equals 5. We don't bring the x's down with it, okay? Like I said, we don't care about them as we're going through the process. Then, everything that doesn't have an x, all my constants, will come down. So we have 4a minus 3b equals -1. So now I have a system of equations, which we can solve just as we have been in the past few lessons. So I'm going to start by multiplying this top one by 3 so I can cancel out my b's. And we'll have 3a plus 3b equals 15. And we'll just bring down the same one from the second. Add them so that our b's go away. So we have 7a equals 14. So a is 2. Okay, great. So we found the first one. We just need to go back and find b. So that's not so bad. I'm going to plug into that green equation up there. So 2 plus b equals 5. And so b will be 3. What this means for us then is that we have finished. Well, we can't just stop with a equals and b equals. We're going to write our equation. So we now know that 5x minus 1 over x minus 3 times x plus 4 separates to equal 2 over x minus 3 plus 3 over x plus 4. So if we were to go through this here and find a common denominator and add them back together, we would get 5x minus 1 over x minus 3 times x plus 4. Okay? So there's the first situation and the simplest one. Notice with this one on the bottom, we just had two factors, two binomials that were being multiplied. Okay? The next one's going to be a little bit different. So in the next case, and it's kind of hard to tell from the definition, so that's why I like to look at the example instead. In the next case, we don't just have two things factored. We have 3, actually. We have x, we have x minus 1, and we have another x minus 1 because it's x minus 1 squared. So this situation separates out a little bit differently. And I'll have a page at the end that will show you each, all of them together so you can see the differences, and we'll go over that. But we've got x plus 2 over x times x minus 1 squared. And what we do with this is we're going to take our x, that's going to go under something, a specifically. We're going to take our x minus 1, that's going to go under b. And then x minus 1 squared, not just another x minus 1, goes under c. Excuse me, the cats are kind of going crazy. So, there's our situation. And what we do now is we just start solving it algebraically. So we're going to multiply through by the common denominator, and that will help us get rid of everything on the bottom. So we'll multiply by x times x minus 1 squared. That leaves us with x plus 2 equals a times, the x goes away and we're left with x minus 1 squared on the top, plus b times the x minus 1, one of the x minus 1s goes away, but we're left with an x and the other x minus 1. And then for the last one, the x minus 1 squared goes away and we're just left with x. Okay, so we go through here and just do some algebra. We've got to FOIL our x minus 1 squared there. That gives us x squared minus 2x plus 1. For this next one, we've got to distribute through. We can go ahead and distribute through bx. Or let's just distribute the x first. So that'll give us x squared minus x. Bring down the cx. And then we need to distribute through a and b. So we've got ax squared minus 2ax plus a plus bx squared minus bx plus cx. Again, I'm going to take this to the next page. And we're going to separate into a few different equations to create our system of equations. Okay, so first off, let's look at the x squared. So we've got this one and this one. There's not one that's set equal, so all we do is we write whatever's with the x squares, so a plus b, and there's not an x squared over here, so we just write equals 0. Next, we need to deal with our x's. So here are those. We have 2a minus b equals 1. Oh, wait a minute. I left off one. The c plus c equals 1. And then last, our constants. So it's just, all we have left there is a equals 2. Okay, so we have our system of equations. This one's going to be a little bit easier to solve because we've already got a, and then up here we've only got an a and a b, so we'll be able to solve it pretty simply here. So I'm going to take, since we've already got a, I'm going to plug into that first equation. 2 plus b equals 0. So b is negative 2. And then for the last one, we've got negative 2 times a, which we already have to be 2, minus b, which we said is negative 2, plus c equals 1. And we solve. So we've got a negative 4 plus 4, plus 2, plus c equals 1. That gives us negative 2 plus c equals 1. So c is 3. So now we can go ahead and write our system, or our solution. So we've got that x plus 2 over x times x minus 1 squared is equal to a, which was 2, over x. Then we've got b is negative 2, so we'll say minus 2 over x minus 1 plus 3 over x minus 1 squared. That's our solution. Again, if we were to find a common denominator, multiply, add them back together, we would get back to x plus 2 over x times x minus 1 squared. Next situation. So again, let's look at an example. For this one, we've got a binomial and a quadratic or trinomial. Since it's a quadratic, that makes us do something a little bit different. So, what we've got is just rewriting what I've got to start with, because we'll have to multiply with it anyway. This time we're going to separate into two equations. On the bottom of one will be x plus 3. On the bottom of the other will be x squared plus x plus 2. So not quite so different. On top of the x plus 3 will be a. Here's where it changes. Because of the x squared on the bottom of the second fraction, we can't just put a b on top. We have to put an x with it. So in order to do that, we have to write bx plus c on top. So we're solving for a, b, and c in this situation. Again, I know it's not real obvious what to do when. We'll go over that more. Multiply by what we have on bottom. And we'll get 8x squared plus 12x minus 20 is equal to, x plus 3's cancel out, so we've got a times x squared plus x plus 2. On the top, we've got bx plus c. The x squared plus x plus 2 cancels out, and we're left with x plus 3. We're multiplying that by all of the bx plus c. So if you leave those parentheses off, you're doing something wrong. You've got to have that bx plus c in parentheses multiplied by the x plus 3 in parentheses. Now we can go through and distribute our a to begin with. And FOIL on the second one. So bx times x is bx squared. Bx times 3 is 3bx. C times x is cx. And 3 times 3 is 3c. So now is the point where we go through and separate into our separate equations. Okay, so the first thing we're going to look at, we always separate by our variable to whatever degree. So x squared, x squared, x squared. There's all of those. So we have a plus b equals 8. Then we look at our x terms. So we have a plus b, plus 3b plus c equals 12. And last, our constants. So 2a plus 3c equals negative 20. So there's our system. And what we'll need to do is we'll need to go through as we did with the system of 3 equations. Okay? And we're going to solve it like that. So I'm going to start with our second equation. And the third equation. And you can see here, and that's supposed to be a 2a. That we could easily get rid of either A or C. Now, which one do I want to get rid of? I want to be left with A and B so I can do something with that first equation. So we need to get rid of C. So to get rid of C, we're going to multiply the top by negative 3. Okay, so we have this here, and then we've still got our same bottom. And we add. The C's go away, so we're left with negative A minus 9B equals negative 56. So now we can take that equation and our first equation, A plus B equals 8, and use them to solve for A and B. Here, we can see we can go ahead and add because the A's go away. That's great. So negative 8B equals negative 48. So B is 6. Awesome. So now we just need to find A. So A plus 6 equals 8. So A is 2. And now we can find C using, using the last equation. So 2 times A, which is 2, plus 3C equals negative 20, and we just go through, and we'll have to pick this up and take it over. So we've got 4 plus 3C equals negative 20. Subtract 4 from both sides, and C is negative 8. Now we can write our equation. So back to our original. And we just write this out for consistency. And we've got over x plus 3 and over x squared plus x plus 2. And we got to plug in A, B, and C. So let's see, what did we have back there? A was 2 and B was 6. And C is negative 8. So I'm going to go ahead and get rid of that plus there. And just write negative 8. And we have now completed example number 3. One more example. One more situation. So this time the difference is we're kind of combining examples 2 and 3 together. We've got the squared on the outside and we've got a squared on the inside. So what do we do with that? Okay, so here's what we do. We take the x squared plus 1 and the x squared plus 1 squared, just like similar to how we did in example 1. And then because we've got that x squared on the bottom, then this time we have ax plus b on the top here, and bx plus c on the top there. And this is all because of our x squared in there. And we go through with a similar process from there. So multiply by our common denominator. And so that gets rid of everything on the left. On the right, don't forget to put your ax plus b in parentheses. And one of our x squared plus 1's went away, but we've still got another one left. And then for bx plus, I wrote that wrong, didn't I? I need a c and a d there. cx plus d. The bottom's going to go away, and there's not going to be anything to multiply, so you could put that in parentheses, or you don't have to. Okay, so then we just need to FOIL here. So ax times x squared is 2. Wait a minute. Is ax cubed. Ax times 1 is ax. Bx times x squared is bx squared. And b times 1 is b. Then our cx plus d tags along. Okay, same as before, except this time we're going to end up with 3 equations because of the fact that we have A, B, C, and D. Okay, so the first one is x cubed. So we need to focus on our x cubed. All we've got there is a equals 2. Well, this is turning out pretty good, actually. Okay, and then we focus on our x squareds. That's the only one we got. B equals 0. Oh, this is nice. Next, our x's. So we've got this one here and here. So A plus C equals 1. Still not too bad. And then our constants. So B plus D equals 3. So we don't have to go through all the elimination and everything that we've been doing. Luckily, we can solve these pretty easily. Because we already have solved for A, then we can plug into this A plus C equation and find C very easily. And because we've already got that B is 0, we can plug into the pink equation and find D very easily. And that's all we got to do, besides write our equation. Okay, so 2x cubed plus x plus 3 over x squared plus 1 squared is, on the bottom of the first one was an x squared plus 1. On the bottom of the second one was x squared plus 1 squared. And then on the top of the first we have ax plus b. Well, there's b is 0, so we'd have 2x plus 0. So we just need a 2x on top. And then on the top of the second one, we have cx plus d. C is negative 1. So that's just negative x plus d, which was 3. And you don't need to worry about moving the negative around. This is good enough. Okay, so I promised you we'd talk about how do we tell what to do when. So here's the situations all put down together on one slide. So if you'll notice the differences between each of these, okay? Here, we don't have anything squared or cubed or anything like that, okay? We just have two separate things being multiplied. In this case, we've got this x minus 1 squared. So that's what made it different. Let's back up a second. So here, we just had the x times x minus 1. So on the bottoms go x and x minus 1. For the second one, for repeated factors, we have x cubed and x minus 1 squared. So here's your example. X cubed, you need every factor of that. So x, x squared, and x cubed. For x minus 1 squared, you need every factor of that. X minus 1 and x minus 1 squared. For irreducible factors, that's what the third one is called, we have x and x squared plus 1. It won't reduce to a regular factor without the squared. So we just multiply x and x squared plus 1. But because of this squared, this x squared on the bottom, plus a number, okay, I know this one's got x squared here, but we didn't add anything to it. But since this is x squared plus a number, then we put our bx minus px plus c on top. And then the last situation is very similar to the second and third put together because we have repeated factors here and here. And this one is also an irreducible factor. So we have every factor of x cubed, x squared, and x cubed, and every factor of x squared plus 1 squared, that's x squared plus 1, and x squared plus 1 squared. And because of these x squared plus 1s down here, then we have two unknowns on top, dx plus e and fx plus g. Hopefully you won't end up with any quite that big, but that's for sake of example. And that now concludes our section on partial fraction decomposition.